Welcome back, ladies and gentlemen. This is Dr. Robinson, and today we're going to continue our studies, and we're going to talk about adding and subtracting algebraic expressions. First, we need to know some terms. Our first term is a monomial. It's a single variable or a number or a product of a number and one or more variables with exponents that are whole numbers, such as 7x, negative 32, 14y squared, z, 6xy. The coefficient is the number in front of the variable, which is a product of the variables. For example, 6 is the coefficient for 6xy. So the 6 is going to be multiplied by the x and the y terms. Polynomials is a monomial or the sum of difference of monomials. For example, 3y, 4x plus 2y minus 3z, 12x squared plus 2y cubed. Binomials are types of polynomials. They are two monomials added or subtracted. For example, 3xy minus 17, 5y cubed minus 20, or x plus y. Notice those are two terms. Trinomial are three monomials added or subtracted. For example, 3y squared plus x minus 17. And here's another one, 4x plus 2y minus 3z. So those are three terms items. So note each monomial is a term of the polynomial. So each individual part is called a term. Well, here's a little quiz. What type of expression is 3x squared plus 9x minus 5? Is it A, a monomial, B, a binomial, C, a trinomial, or D, a coefficient? Well, let's look at it. It has the 3x squared, it has the plus 9x, and it has a minus 5. So there are three individual terms. And if you remember, 3 is like a triangle has three sides, or a tricycle has three wheels. A trinomial has three unlike terms. So if you pick C, you are correct. Here's one for you. What type of expression is positive 9y cubed minus 5? Is it A, B, C, or D? Tune in to class and we'll figure that out next time. Check your understanding so far. See if you understand the terminology. If you have questions, write them down. I'll be glad to answer them in class. Here's our first question. We're going to simplify the expression by combining like terms. We have 9a plus 15a. These are terms that are monomials, and we're going to combine them because they are alike. We could consider 9a to be like 9 apples, and we're going to add to it 15 apples. Well, 9 apples plus 15 apples would give us 24 apples. So all we had to do was take the 9 and add it to the 15, and that would equal 24. So all we're doing is adding the numbers. And don't forget to put the A on the N, because you're talking about apples. Here's another way to look at it. We could use the distributive property, where we have 9a plus 15a, and we have a common factor of a, which we would be multiplying by the 9 plus the 15, because 9 times 15, 9 plus 15 times a would be the same thing as adding 9 and 15, which would give us 24, multiplying by a, that would give us a times 24, or 24a. So you can look at it by the distributive property. So we're combining like terms. So the main thing to know in combining like terms, you have to make sure you have the same variable that you're combining. So if they're both a's, combine them. But be careful, if the exponents are different, you cannot combine them because they're different items. Here's a question for you. Which expression is equivalent to a plus 3a plus a? A, 5a, B, 5 plus a, C, 3a cubed, D, 3a squared plus a. Well, remember what I said about apples. Here we have an apple plus 3 apples plus an apple. So give it a shot. What do you think it is? Give you a couple seconds. Okay, if you said C, you are wrong. That 3a, I know you have 3 apples, 3 apples, 3 apples, and an apple, and 3 apples plus an apple. But this 3 apple would be 3 individualized apple, and this one little apple would be just one apple. So what's important to know is one apple, 1a, is the same as saying a. So that's important to know. So if I had one apple plus 3 apples, that's 4 apples, plus one more apple, that would give me, yes, you got it, 5 apples. So our answer would be A. So keep in mind, A is equal to 1A, whereas 1A plus 3A plus 1A would give us 5A's. We would just add the numbers in front. 1 plus 3 plus 1. So check your understanding. If you need to watch the video, again, rewind it and write down your questions, and I'll be glad to answer them if you're still uncertain. Let's move on to another way of dealing with this. Here, we're going to simplify our expression, and I have a chart that we use. And we're going to carve up this expression, 4r plus 9 plus r plus 2s minus 3. We're going to cut that up into different parts. So let's cut it up into different parts. So I'm going to divide each part between the sign, so that way I have it separated. Now that I have it separated, I'm going to take each term and put it underneath in the chart. And I'm going to check off each part underneath that I've used. For example, constants or numbers. So I'm going to take the 9, which was plus 9, or we could also say positive 9, and I'm going to check that off. Check. And then I'm going to take the minus 3, because that's a constant. Constants are numbers. And I'll check that off. Check. Did I use that? So notice all my constants are gone. So now I'm going to get my answer for the constant. So my answer for plus 9 and minus 3, when I combine that, I would get positive 6. Because different signs I subtract and choose the sign of the larger digit. So far I've gotten my positive constants and my negative constants in my chart. Now I got to get r's in the chart. So let's get my r's in a column as well. So I got r's, and I'm going to put them in a column. Oop. I'm sorry. There we go. I'm going to get a column called R. And since R was the first one, I'll make that the first column. And I'll take my R's and I'll put them there. So here I have a 4r, and I'll put that in that column, get my pen, and then check it off. Check. Any more r's? Ah, here's a plus r, positive r, or plus r. I'll check that off. Check. Are there any more r's? I have a 2s there, and everything else is checked off except that 2r, 2s. So let's start adding that up. So I got 4r plus r. Well, if you remember before, we talked about uh, having just one little r. In algebra, they don't write the number when it's just one r, so the coefficient or the number would be just the 1 that's missing. So we would have one little r there, and we have 4r plus one little r, which would give us 5 r's. So now we have, so far, our r's taken care of. Notice they're checked off. Our constants are checked off. The only thing we don't have checked off is our s column. So let's get our s's in there, make a title heading for them, and we'll put them in there, right in the middle. And now we'll grab our positive 2s or plus 2s and put that in there, and let's check them off that we've done them. And notice everything is checked off, and now we can just add up this column because we're simplifying the expression. We have positive 2s plus nothing is just positive 2s. So our answer is going to be 5r plus 2s plus 6. It's a trinomial. So when we simplify expressions, a good way to do it is to make columns. Get your like terms together, your r's together, and get your constants at the end, and your other variables, get those in there as well. And you put them in their own separate column and just combine like terms. Here's one for you to try. Simplify the expression 2k plus negative 3m minus 6k plus 2m. So give that a shot in your spare time. See if you can get your constants in the columns, your k's and m's in their respective columns. Here's another one. Simplify the expression by combining like terms. 1/4 z plus 8 plus 3/4 z minus 5. Good question. Fractions. Check for your understanding. If you need to rewatch the tape, please do. If you have questions, write them down. I'll be glad to talk to you about them next day. So here's some notes you should know. The same rules that you learned in the adding and subtracting rational numbers apply to adding and subtracting algebraic expressions or polynomials. Remember that subtracting an integer is the same as adding its opposite. So we're going to do a question on subtraction since we haven't talked about subtraction yet. And I want you to notice we have 4x plus 8 minus this binomial here in parentheses 3 plus 4y. So we're going to subtract this stuff. If you remember, we said it's the same thing as adding. Subtraction is the same thing as adding the opposite. So I got to make everything in here the opposite. So what I'm going to do is I can multiply this term and the second term by a negative 1 here. And that's by distributing the minus. So that way it would make this whole thing inside the parentheses its opposite. So I'd have negative 1 times 3. That would give me plus negative 3. And then I would multiply negative 1 times minus 4, and then times positive 4y, and that would give me a minus 4y. And I want you to notice it's the same thing as if I would just change the sign of the second number to the opposite. So here I have changed this to positive 3 from positive 3 to negative 3. Change this positive 4y to its opposite, negative 4y. So I'm really, in a sense, adding the opposite. Notice everything is the opposite of what it was. So let's bring back the 4x and the plus 8. So now this is where we get our like terms together. So let's see. Let's deal with the constants first. That's our numbers. I have a plus 3 plus a negative, I'm sorry, I have a plus 8 plus a minus 3. And what that's going to give me, remember, the same signs, I would add and keep different signs, subtract, and that would give me a positive 5. So when I combine the 8 and the minus 3, I get positive 5. So there's my constant, positive 5. And when I see what I have left, I have a 4x, and I have a minus 4y inside the parenthesis that's left over, minus 4y, because they're in their own separate column, and I don't have to combine them because they're different terms. So I'd have 4x plus 5 minus 4y as my resulting answer when I combine like terms. So that would be my answer. So when you subtract, the key thing to remember is to change whatever is the second term to its opposite, and you're using addition. So you're adding on the opposite of the second term. Here's a problem for you. Subtract 5r plus 3 minus 1 plus 6r. So give that a shot. See if you can get it. Check for your understanding. If you don't get it, rewatch the tape or write, and as well as write down your questions, and I'll be glad to see you in the morning. Here are a couple questions dealing with word problems. Karina bought a ruler for $2 and a compass for X dollars. She paid for the items with a $5 bill and Y dollar bills. Write an expression in simplest form that represents how much money in dollars she received in change. All right. Well, the first thing I noticed, she bought some equipment for her class, $2 for the ruler, and a compass that didn't tell us how much. They said it was X dollars. So a cost, $2 plus X dollars for the ruler and compass. We would add that together to find out how much did she spend. And it says she paid money with the $5 bill. So she paid the cashier with a $5 bill, and she also gave Y dollar bills also. So the money that was given was 5 plus Y dollar bills. Now, how much money in dollars in change would she receive? Well, I would have to subtract my money that I've given them from the cost. So it would be $5 plus Y dollars minus $5 plus $Y minus the cost that the things cost me, and that would give me the result of how much change I get. So there would be my expression, and now I have to simplify that. So remember your rules for simplifying. Change this to an addition problem, and everything else inside the parenthesis gets changed to its opposite. So the 2 gets changed to a minus 2, and the x gets changed to a minus x. So we have 5 plus y in our first parenthesis plus negative 2 minus x. Well, I see we have constants there. We have a 5 plus we have a negative 2, which we can combine. Those are constants. And when we combine that, subtract them, 5 plus 2 or 5 minus 2 gives us 3. Because same signs, we would add the numbers, different signs we would subtract and choose the sign of the larger digit, so we would get 3. So that would be our constant. So we got, what do we have left? We have a plus y. We have a plus y left. And we have, and on this side, we have a minus x. And we have the $3 change from the constant. And that's what would be left, because we don't know what x and y are, but when we do find out, we would be able to combine that with the other terms, the constant. So our answer would be 3 plus y dollars minus x dollars. That would be our result. And here's again how I did it, so you get the same answer. So this was a very good problem with words using algebraic expressions and polynomials. So I hope you got something out of it. Here's another question that you can try for yourself. Write an expression to determine the perimeter of the triangle below. So see if you can figure it out. Remember, perimeter is the distance around the figure. You find that by adding all the sides. So I hope my lesson was easy, and we'll work on it tomorrow. Remember, if you need to watch the tape again, please do, because we'll be glad to answer your questions. This is Dr. Robinson signing out. Bye-bye.